we can assume that our end plate, right, is correctly oriented. And what we're going to do here is I'm just going to put everything at the origin of this assembly, starting with a end plate here. I'm going to put this at the origin. And the way I can do that is simply by moving and using my object snap. You can see there I got the center of the front hole on the face there of the end plate. And I'm going to move that to 0, 0, the origin of the assembly there. Okay? Now, you can test this to make sure you have the right orientation. Take a look at top view. All right? Is it what you expect to see? Take a look at front view or any other view that you want to take a look at there. Once you're satisfied, then you can go ahead and start aligning all the other parts. Now you'll notice, if we take a look in the right view, let's take a look here. Notice that all of these parts, all we have to do is actually rotate 90 degrees in this plane, right? And notice, because I used a standard view, notice how the UCS is also changed. This is how I can use regular 2D tools to work with 3D objects. So for example here, what I'll do is one by one, let's start with the center pin here. I'll just rotate it using the 2D rotate command and then just using my polar tracking method. We'll do the same thing here with the corner pin. Just picking a base point anywhere in space and making sure we do a 90-degree turn, right? Do the same thing here with the disc. And then also our spacer. This really saves us a lot of time here. And as we go back into our southeast isometric view, we can see basically all we need to do now is bring them together. So now as we proceed to create the collapse view, let's put the parts together in the order in which they come here. We have the end plate, we have the disc, spacer, corner pins. Okay, we're going to put all four together there. The other disc, the other end plate. We are not modeling the bolt or the nut. We can then bring in our center pin. So let's take a look. Alright, so continuing with the disc here, let's pull it closer. Just using the move command here. And what I want to do is I actually want to rotate it and make the face, the front face of the disc here, coincident with the back face of the end plate. And I also want to align the center of this slot, right, with the center of the holes here. So the tool I can use is the align command. Now generally what I would like to try to do here is be able to see both faces, right, in order to do this more easily, because it's going to require that I rotate around the object in order to do that. So let's try this. Let's orbit, and you can see what I mean here. I pulled it too close together, so this is the face that I want to align it with here. What you can see as I rotate or orbit around here to see it, now I can't see the front of that face, right? But let me show you something here. If I go to World UCS, look at a top view, look at this. I'll rotate my disc, just to illustrate this to you, at a 90-degree angle here, okay? I'll move it in space behind the end plate here, and then let's take a look at a side view there and pull it down, again using polar tracking here. And let's take a look at the right view so we can have the right UCS. And then that way I can just move along the y-axis there. And then let's switch back to an isometric view. Or let's look at the other isometric view. There we go. Okay, let's turn off that grid so it's easier to see. So now you can see both faces, right? And the idea here is to show you how to use the align command. So with the align command, we can use up to 3 source and target points. Think of it this way. We know that the slot here has a radius, and that radius has a center. So let's assume that center is coincident or concentric with the center of the holes here. The way that those slots are spaced, they should align perfectly. So we can have the first source point here, second target point. First source point here, second target point. And then we could use a third. Okay, so let's try this. Let's go ahead and use align, type AL for short, enter. What we're going to align is actually the disk, so let's select the disk, hit enter. Let's go ahead and zoom in. You're using your object snap modes. I'm going to zoom in to make sure I get the center there on the front face, and then I'll link it to the center here on the back face of the end plate. That's my first source and target. Come over here to get the second source and target. Now, I'm pretty sure we could do it with 2, but let's just go ahead and pick a third. Here's the center and the center over here. Now you can see the object is perfectly aligned. If we take a look using the top view and zoom in, even if you change the display to wireframe just so you can see if any of the lines are embedded, you can see it's perfectly aligned there. Alright, well, now as we proceed, okay, so we've got our disk to the end plate there. Now we could bring in our spacer. So once again, this should be easier to select. You might even choose to switch to a wireframe view for this. That way you can see both ends. And again, because I know it's already aligned to each other, I'm just going to select the object and use move. And with my object snap modes, select the front center there. Zoom in over here and find my end plate center. Okay, we got to be careful here because we may be snapping to one of those holes. So if I switch back to conceptual, I can get a better look, and I could also always switch to my 3D orbit mode. So as we continue, the next thing that we could bring in is going to be our second disk. Okay, and what we could do here is simply select the previous one. And again, what we want to think about here is also when you're looking at assemblies, let's take a look at the top view real quick here. And the way this assembly comes together, you'll notice that the face of the spacer is coincident with the face of the disk here. So you got to think about how the corner pins are going to come together and their overall length, how far into the end plate they're going to fit. Are they going to be a loose fit or a press fit with the disc? All of these things are going to be important to consider, which might impact the changes that you make to the assembly. Okay, so if we just generally put it together here, let's go back to that northeast isometric view. And what I could do here is if I just select my disk and I use the move command, again, it might be difficult here to be able to snap to the front or the back face of that disk, but I'm just going to click anyway and just pull it to the side, right? Actually, I'm sorry, I should do copy. I don't know why I was doing move, but here we go. I'll select it again, right click and use copy selection. Pick a base point and just pull it to the side. That's hard to tell for me if I know if that's the front or the back. Let's escape, and now we can use the move command. Select the disk, hit enter, and now we can easily see whether the front or the back face center is selected. Okay, so I want to make sure that I have the back face center. From there, I'm going to align it with the front face center here of the spacer. Now you can see that both disks are still aligned. And as we proceed, we can then go to the corner pin. Let's just move this one closer. Okay, so we can work with it. What we need to do here, at least for the collapse view, is we need to show an array of these corner pins. Now, first let's position one of them, and then we'll create the axis that'll represent the axis of revolution for the polar array. Again, this is where we want to think about what's the overall length of our diameters here for the corner pin and how we propose for it to fit together. As you build the assembly, you'll be able to see these either collisions or gaps, depending on, again, how you envision the assembly coming together. For now, what we're going to do, so I'll be using here move command, selecting that corner pin, and notice how I'm going to snap to the center here, right, of the larger diameter. This face here, I'm going to make it coincident with the back face of the disc. So I'm going to hover over here, make sure I snap to that back center, right, and place it right there. You can see now how my corner pin is embedded in the end plate, right, and you can see over here opposite how the face is coincident, right, the larger diameter of the corner pin is coincident with the face, the back face there of the disc. Alright, so we got that corner pin placed correctly, and now we want to create the array copy. What we'll need here is an axis. So let's go ahead, return to World UCS, okay, using Object Snap and Polar Snap. Let's just draw a temporary line, just a line in space. What I'll do here is I'll snap to the center of any one of these components that are aligned and just simply draw a horizontal line in space. Okay, as I orbit around the object, you can see how it's centered on the assembly, right? So to make our copies here, what we could do is let's go ahead and take a back view. This way we can just use the regular 2D array. Here's the back view, right? And you can see there's my axis. And if I switch back to an ISO view, I'll maintain that same UCS, right? You can see that right up against the end plate there. So now I'll use the polar array command. I'll select first the corner pin, hit enter, and now take a look at your options, right? You'll see base point or select axis of rotation. I'll use that option, okay, and with the line that I drew here, what I can do is I can use 2 points on that line. For example, the midpoint and the end point on that line that represents my axis to create my copies. Once you start the command, look up at the properties here and you could determine the number of items and then also the angle of fill, which is going to be 360. So there's our 4 copies. Just click enter and you're exiting the command with your copies. Now we can get rid of that temporary line for now, and then we'll finish off with a copy of the end plate and then positioning that center pin. So all we need to do here with our end plate is, let's see, we know that we've got the back face here of the disc that's going to be coincident with what would be a copy of the end plate, but coincident with the front face. So let's do that first. Let's make a copy of the end plate, pull it along, maintaining the same axis, pull it along some distance away, exit the copy command, and now you could do this a number of ways, all right? But what I'll do here is I'll switch to wireframe. That way it'll be easier for me to see this front center here and also be able to snap to the disk center over here. Let's see if we can do that. Let's use the move tool, select the end plate, snap towards the center of the larger hole, okay, so now as I zoom in here, this looks a little bit more difficult than expected, but let's see. I got a center right there, I believe. Alright, let's switch back to our conceptual just to see what happened there. If I take a look at the assembly from the top, there we go. That looks like it's all aligned there. And then lastly, let's take a look at our center pin. So this actually has to be flipped over, right? Because we're treating the side over here as the front of the assembly. So let's take a right view, okay, and we'll rotate in space here 180, and we'll move it towards the front. And then get back into an ISO view. Okay, so what we know is here's the head. We're going to use the center of the head over here to be coincident with the center of the large hole on the end plate here on the front face. Let's go ahead and use move now. Select the center pin, zoom in so we could snap to that center on that back face of the head, and then come into the end plate. Let's see. Oh, no, that shifted there. Now, let's undo that and let's take a look. Remember, we have layers, right? If we have too many objects here, remember, since we have our layers, what we could do is we could temporarily freeze any of these other layers so it doesn't interfere with our alignment here. Okay, there's less objects. So let's try again. Let's move center pin, let's zoom in here so we can snap to that center, and then zoom in towards that front face of the end plate. Let's see, I think that's it right there. There we go. And then we could orbit around or take a look from different views to make sure it's aligned perfectly. So there's our front view, here's our right view, and if we take a look at this in wireframe, we could also confirm that everything is aligned there. Great. Let's switch it all back to conceptual. Let's make sure that this is southwest. Let's go to a southeast. Let's make sure that for our layers, we're showing all the other ones too. Okay, there's everything there. And short of the bolt and nut, now what we could do is make a copy of this so that we could create our exploded view.